Um, what is a scope? Not that. Okay. All right. So what is a scope? A scope for us in ES5, a scope is a curly brace, right? And not just any curly brace. Usually when we talk about scopes in ES5, it is the curly braces of the function that we're in. Okay. And the reason why scopes are really important is because think about it this way, right? When you're inside the function, right, you can see what's inside the body of the function. You can also see what else is outside of the function, right? But when you're outside the function, you can't really see what's inside the function. It's almost like a one-way mirror. Like when you're inside the function, you can see outside of it, but when you're outside, you can't see inside of it. And so how we set scope is very important in programming and really all languages. And the reason why is because what we set and where we set it tells us where we can access this particular variable or this particular value. So in ES5, function scopes are by far the most important. We also have curly braces for if statements, or for if loops, for while loops, for loops too. And we'll talk a little bit about kind of why those scopes also matter. We saw an example yesterday, right? Where in a for loop, if we do break versus continue, it means very different things, right? Break helps us break out of that current loop, right? Return gets out of that current function. Continue helps us iterate to the next version of it. And in that case, then like where we write the word continue is super important, right? Because what continue is going to do is say, okay, great, I'm somewhere. Let me look for my nearest curly brace, right? And I'm going to break or I'm going to continue from that curly brace onwards. So scopes are very important in terms of defining kind of where something is created and who or what has access to it at what point in time. Functions can see inside their own scope, right? So inside of a function, you have access to everything in between those curly braces, as long as it's not inside another set of inner curly braces. Because that means you can see what's inside of where you are, you can see what's outside of you, but you can't see what's inside another function, right? So a little bit tricky to explain in terms of, a little bit tricky to explain verbally, but it's just this idea that like scopes only work when you look outwards, not inwards. Okay. So when we look at something like this example here, right, we have this function called add5. We have a variable n. We say bar num equals 5, return n plus 5. Does this function work? Like if I try to run this code in REPL, would it give me an error? Would it say, your answer is whatever?
It hasn't been passed.
Justin? No? Good?
Has it been passed?
Yeah, that's like we're passing a 3 right here, right? 3 is the argument, and then when it makes it into the function add5,
yeah, that would work.
That works, right? On line 3, we're returning n plus num. As of line 3, do we know what n is? Yeah, because it's a parameter, right? Do we know what num is? Yeah, because we define it inside the function. Great. We have all the parts. When we run this will say, great, your answer is 8. Okay. How about this? Does this work now?
No, it's not inside the function. Oh, but it's still sees.
Yeah, the function can look out.
I can see.
Yeah. So this works. Probably not for the reason that you think, because this num here is not this num here. And here's the reason why. There's 2 parameters being passed into the function, right? There's n and there's num. Okay? And so on line 12, when it says return n plus num, yeah, we have access to both of those values. But those values are what's here, not necessarily what's outside.
Yeah, but it is being fed in via the function.
It's being fed in here,
Yeah.
but like,
It's the same value, but not the same variable.
yeah, and really in like programming, like you never want to hinge too much on the name of the variable because that's very it's very esoteric, right? I can change anytime.
So that bar num isn't doing any, or it's not useful at all.
No, it is. It's being fed in at the bottom.
Yeah. So this is actually a very super important this is a very important concept to realize in JavaScript, right? Which is one of the reasons why people have scopes is to say, hey, there's this global variable, or sorry, not there's this variable with this name, right? And you know what? I also want to use that variable in my own function, but I want to call it something different. At that point, what I can do is I can override what we call the parent value. We can override that variable value with our own version of num. So the quick example I'll give here is this. Okay, so I say var x equals, let's say 6. Nope, not in 16 array. Var x equals 6. Cool. Okay, and then I'll do console.log out x, and I put down x. I get 6. Right? This is as simple as we're gonna get. On the other hand, if I do something called like a check again, function check again, I have something called or I don't pass anything in for now, and I just do var x equals 9, and I console.log out x. We'll say inside func. And then I'm going to actually do this again out here, and I'm going to do outside func. Something didn't print. Oh, that's because I didn't call the function. Haha. Check again. Okay, cool. Okay. On lines 1 through 3, I define x as 6. I print out x equals 6. Really great. In check again, I say, hey, x is 9. Print out for me I got x inside the function, and it's 9. But realize, like, this has access to this x equals 9, right? Out here on line 11, remember, you can't see inside other functions, function scope. And so as far as line 11 is concerned, the value of x is the last accessible value of x for it, based on where it is on this page. And in that case, it's not on line 6, it's on line 3, or line 1. Yeah.
In console.log, is there a way to tell it to print the outside x? Basically tell it not to be overwritten.
Line x?
On line 7, is there a way to console.log to intentionally print the outside one?
Not
without any kind of feeding or without any kind of...
no. Not the way we currently have it written, because line 6 completely overrides x.
Got it.
But is that the question?
Yeah, no, I get that, but so let's just say, like, hypothetically speaking, you took out the line, like you made x a parameter in the function,
Yep.
in the function, and you took out line 6.
Okay. Anything else?
Would check again then return 6?
Good question. What would check again return right now? Who can predict for me what line 6 is in a console log out now? So we have one for undefined.
Undefined.
Knows? Right. It's undefined. Right? Do you see why that is, Becky? It's because now this function here again is expecting a value. Right? When we invoke it, we don't give it anything. Right?
What if you took out the x in the parameter?
Oh yeah. Then yes. Then we'll just get.
Then x is still 6.
That's okay. So we have one vote for 6. Anyone else have any guesses as to what x is gonna be? Ever unanimously thinks it'll be 6.
We're not telling it necessarily what x means.
Yeah, we did at the top.
Nothing function here.
Yeah, the function can read outside of it. Facing the absence of being overridden and leaves with the current value is.
Cool. And so this is the other important principle of scopes, right? Is that if I on line 6, if I'm telling it, hey, print out for me x, the first thing JavaScript does is let me find the latest version of x. And the latest version of x, it will always look in its own scope first. If it finds it, it will print out and it will move on with its life, or move on with this process, right? If it doesn't find it in its scope, it will look in its parent function scope and say, hey, do you have a version of x? And the parent has a version of x, they'll say, okay, great, give me that, and now I'm gonna move on, right? If the parents don't have it, they'll say, great, do your parents have it, right? And this is what we say, scopes, it looks outwards, right? It looks in its own scope first, always, then it looks for its parents, and then it looks for its grandparents, etc. Not sure if this is the best analogy or not, but you know how like when you need to buy something, right, you look for your own bank account first, and if you can't afford, like, hey mom, dad, do you have anything to help me out with? And then you go to your extended family and friends network, right? maybe not the best analogy, but the same idea, right? You always go to your own scope first, and then you go to the next scope that's closest to you, and then you go to the next scope that's closest to that, etc., etc. So you're always looking outwards, and as soon as you find one, you're done, right? It doesn't matter if you're, let's say, back to my bad analogy, it doesn't matter if your grandparents can afford it, because if you can afford it, like, you pay for it first, right? It's kind of like almost like we have a loan, like you have like quality of debt, like your own scope is always the highest priority. You look for all the variables in there first, and then you gradually look outwards.
So basically, like, let's say, again, like, if you put x back in, if you declare a parameter, it's pretty much like reassigning whatever
Yep.
variable.
Yep. And so this is something that like I'll kind of harp on a little bit, and you'll definitely see a lot more of this in the practice problems today. Whenever you see something in the parameter, you don't see it, but you can almost imagine like JavaScript is saying, hey, there's this comment of var x equals something here, right? This line, you'll never see it written, but that's essentially what JavaScript is doing. JavaScript is saying, hey, let me create this new scope, and because these are parameters, let me just recreate all of these variables that will supersede anything that came before it, right? And JavaScript won't even bother like looking with previous values. It doesn't matter to it, right? Like you're saying, you're telling me to create a bunch of brand new variables with these names, with these values, so I'm gonna do it. Whatever was there before, I don't know anymore, right? If you want to keep those values, make a better name. That's pretty much what it comes down to. Cool. Okay, cool.
I have a quick question
Yeah.
about semantics. When you say look outward, how would that be? Is that different than saying then look up? Because wouldn't the scope be what's higher? Or could you have code that's lower and it's
Yeah, it depends on how you write it, like where you nest things.
Sure.
Like in the last thing where we had like we move one of the for loops to underneath the function. That's an example where like up or down is like a human term in terms of like where it is on the page.
Yeah.
Computers look outwards, right? It'll say like, who's calling me? Great. Who's calling that? Great. Who's calling that? Great, right? And so the way the computer sees it, it has very little to do with like where it is vertically on the page.
Sure.
It's more like who's calling me, who's calling that, who's calling that, and each of those instances is a version of looking outwards. Looking up, and people will probably say it, but I guess in my mind it's always looking outwards because the scope could be beneath me, right? It just doesn't matter where as long as someone's calling it in the right way. Okay, cool. So we're back here now. This function obviously clearly works, right? These two numbers, they're parameters. This num here is the value, right? We're good. And then lastly, we have this person here. So as the example is hopefully kind of proven to you, the n is still a parameter. We're really good there. We have that value locked away. And then we're looking for num. Well, is there num in the add 5 scope? No, there's not, right? There's nowhere in between lines 20 through 22 do we ever say num equals something, right? So then the function say, okay, I don't have a num. Mom, dad, parent, do you have a num? And we're like, oh yeah, we have one on line 18. All right, great, that's the next value, right? Cool thing here is there could be other nums elsewhere on the page. Doesn't matter, right? Or there could be other values of num in other functions. Doesn't matter. This is the one that's closest to me, so to speak, or this is the one in the scope closest to me. So this is the one I'm gonna run with.
So with best practice, we can always redefine it so that we can guarantee that we'll have the value that we intend.
Yeah. So one common practice when we hear people say, "Hey, your code should be very modular," is what that means is every function that you write should do one thing and do it really well, right? So the previous example of counting number of vowels in the word is a really good example of like, hey, this function, don't try to do too much, right? Just count for me the number of vowels in the word. That's all I need from you. And in an ideal world or in an ideal code, every function is very standalone or modular. And what that means is that function is being passed into it all the things that it needs to run, right? It's not looking for some magic number somewhere else on the page. Like if I say, count the number of vowels for me in the word, in an ideal world, I would tell it what's a word and what are things I consider vowels, right? And with those two information, this code can run without dependence on anything else on the rest of the page. And in an ideal world, that's how your code should run. It's not what happens in real life, but yes, like in an ideal world, like there should be as little ambiguity about variables as possible, right? the function should know exactly what it's looking for and what it's doing. And then lastly, we have this guy. Does this work here?
Nope.
Why not?
Num never gets fed in.
Yep. So here on line 32, right, we're returning n plus num. N exists. Great. Num. Do I have it between lines 30 and 33? Nope. Okay. Parents, do you have it? No. We don't. Right? Back to the really crappy analogy here. Like maybe your brother has money or your sister has money. Well, you don't really have any access to that one, so you're kind of out of luck, right? Like someone else has a variable. That's really great, but guess what? This is inside their scope, right? You can look in your parents' scope, but you can't look in your sibling scope. I keep using the mom, dad, and family analogies because computer science does see a lot of this in terms of familiar relationships. You'll hear parent scope, sibling scope, children a lot, and so that's why I'm kind of running with that particular set of terminology. But yeah, this is considered a sibling scope, and you have no right to look in other sibling scopes.
However, in the function, you really can't look into another function.
Yep.
You can access what the function produces.
Yep.
For example, if that first function were to return 5, can you then define number in the second function to say n plus whatever that first function returns?
Yeah, definitely.
Assuming that-
Yeah, I mean they're just calling a function, right? They're just running JavaScript in that sequence, right? The idea here is just like because this is a return thing. The idea is this num value is only ever going to exist inside of it. If it ever decides to spit it back out, that's a completely different story. But in this case, because it's completely internalized, no one else outside of create num has access to that 5. And really, like it's one of those things that like it may seem kind of frustrating at first, but when you think about it, like it kind of makes sense, right? And like when you build software, especially when you start thinking about security, like you don't want everyone to have access to everything at the same time, right? Like really, like like when you like let's say you start working at Google or Microsoft, right? No one says, all right, cool, day one, all right, here's all of Google's source code, go knock yourself out, right? It's like, no, you're doing a job. You need these 4 things to do your job. You need security clearance at this level. There you go. There's the minimum. You need to do your job. Now go do it, right? Like it kind of reflects a lot of the way that we want to think about code too, which is like we want every code to have a very direct purpose, and we want it to have all it needs to do its job, but nothing excessive because there's no point, right? If anything, it will always be a liability, never a benefit.
So you were saying that it was outward, not above. Because for some reason I was kind of thinking that it had to be above. So in this particular example, what if on 37 I returned the function add 5, and then on 40 I put num equals 10? Will line 37 be able to understand the num that I entered on line 40?
Yep. The answer is no, not in the way that you think it will. We'll talk about it in like 3 more slides when we talk about hoisting. Yeah. So right now this is more about like scopes. What we're talking about is hoisting, which is hey, in what order does JavaScript read things on a page? Scope is more assuming everything on the page is kind of being read already and it's being whatever it's kind of all there on the page statically. What you're talking about is hey, can I invoke a function before I write down what it is, like maybe lower down the page. And we'll talk about that when we talk about hoisting, which is how JavaScript actually like ingests code and what order it ingests code on a page. Okay, and then just 2 more examples here. Yep. One on the left, no one can ever see create num, right? In this console log, there's nothing called num here, so I'm going to tell you num is undefined. But, and this is I think we asked Cash, right? So like, if I create var num equals whatever and I return a value of it, yeah, I can totally store that, right? Now I'm just calling a function and just storing the value, which is pretty much the basics of programming. So, does everyone feel okay about the idea of scopes and looking for variables and kind of where to find it and where we can't find it in some cases? All right. Functions create scopes. And this is just another belaboring the point of you can see inside your scope, you can look outside of it, but you can't see inside of other people's scopes. Yeah, I mean, this is telling you like, hey, num1, we're cool, right here, line 2, I have it. Num2, this is a black box, and so if we remove the black box code, there's nothing called num2, so this will be reference error. Right, that'd be a reference error because we never define it anywhere. All right, global scope. Okay, global scope. We talk about global scopes mostly in context of browser, but even when we write anything, right? Let's say you're like, hey, does my parents have it? Eventually, you stop, right? You kind of reach the outermost scope, the outermost page layer. You say, do you have this variable? And the answer is no. Then you're saying, okay, we don't have this variable, right? You only look so far, and then you eventually stop. That outermost layer is called the global scope. And it's called the global scope is because everyone has access to any variables that climb there, right? Because it's like, once again, family tree, right? Like if you go back to like you're like, let's say you assume that like, humans started with, one particular, couple, right? That couple is a global scope, right? Like everyone traces back to that. Like that's like the origin, the starting point. And so in that case, like everyone has, everyone traces back to that. And if that doesn't have what you need, if that global scope doesn't have what you need, then it doesn't exist. And in most browsers, the global scope is called the window, right? So if you're looking for a variable on the global scope, you say window.myGlobalVariable, whatever. So yeah. Oh yeah. And so yesterday I said, guess what? You can say x equals 6, right? We don't always need to say var x equals 6. I think that one maybe one of Justin's questions. And the reason why you never want to do x equals 6, you always want to use var is because when you do x equals 6 or you do that without saying var in front of it, var puts that variable on the function scope. If you don't have the word var, JavaScript is going to assume you need to put it on the global scope. Okay? And so, just like yesterday when we had the double equals versus triple equal sign, I'm telling you that window variables exist, and I'm telling you that double equals exist, but you should never use it. Same thing here. The global scope exists. You should really never, ever use it. Yeah.
So yesterday, something that came up when I was working on the practice problems was in like for loops, whether you should declare the variable at the beginning when there I equals whatever, or if that can just be like I equals 0, and does that have something to do with the global scope?
Yeah. I mean, it will run. At that point, it will put the I on the global scope, so anyone else has access to I, which is just never like. There's very, 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 very few reasons why you should ever have anything on a global scope, right? And it comes back to the fundamental idea that like, okay, who's using this, right? If it's being used by a function or by a particular scope, put it in that scope. There's no reason why you want to have things on a global scope for two reasons. One, security, right? Anyone from anywhere on the page can access it, and a lot of times, especially if you have something very sensitive like username or passwords, like those things do not go on the global scopes. There's something called environment variables, very different idea, and that's where it's a more secure way of putting things in a place that everyone can get to it, but the global scope is extremely insecure. The second reason why you don't want that is because you don't know who else is editing this variable, right? Like if I say var x equals 6, I know that whoever edits x, they're going to live inside this function, right? If you're not inside this function, you don't have access to it, you can't touch it, right? On the global scope, you have no idea who's editing, right? It could be like you could say, hey, x equals 6 on some line, right? And then other functions could be changing x like on the fly, doing whatever they want to it. And then when you try to use it much later in your code, you're like, wait, this isn't the value I created. Well, it's like, well, other people have been editing it because you created a variable without your scope, right? So anyone can access it without your permission. And so for security and also just for ease of use, global scope, never use it. Yeah.
So in some sense, a var is weaker than just an equal sign. But if you have
a var is weaker than an equal sign.
Just like because in some sense, it will just be accessed everywhere.
Sure.
It's just the equal sign. But if somewhere in the code there's just x equals whatever, and then you have a var line, does that var line? What's the right? How do I refer to that var line? Is that correct?
Just say var. It's a variable. Yeah.
Okay. Does that var supersede that x equals somewhere else in the code?
Yeah, it does.
Okay.
It does. Sorry, I'm just checking the time to make sure we're not like super behind right now. It does. But like it does supersede the global scope. In that regard. But if you're overriding a global variable, it really begs the question: why does a global variable even exist in the first place? Right. So like and I mean, this is maybe more of a philosophical argument, but just for now, for our class, for the next few weeks, just don't use global scope. It's there. It will work. Once again, if you try to do x equals 6, Java will say, great, let's keep it moving. And you're like, wow, I don't even need var. But you do. This is why.
Maybe if you write var equals whatever outside of a function, is that also
Var what?
var equals whatever, like you declare a variable? We're
Yeah.
talking about that, right?
Yeah, we're just talking about like so
If you use the word var to declare a function, variable, like that, outside of a function, is that within the global scope too?
we're talking about like it doesn't matter what's on the right hand side of the equal sign. It's more like on the left hand side, right?
Yeah.
So x equals 6. Oh God, I hate how it does this. Really? There we go. 7. Nothing starts with 7. It's not a base 2 number. Okay. What we're saying is x equals 7 and var x equals 7 both work. And it doesn't really matter what 7 is. 7 could be a function, an object, an array, whatever it is. Both of these things will run. But this puts x on the global scope. This confines it to whatever scope it's currently in. And so it's accessible to it and its children, but not its parents.
So we should always use var.
Always use var. Yep, that's a pretty good summary of it.
And I don't want to go into this right now, but in this class, we can just talk about let and how we use let. Oh, because I've seen that a lot.
Yeah, probably not right now. I mean, I guess like the shorthand version of things like let and const is, well, there's a few use cases for it, but relative to scope, right, is right now I've told you that scope only works when you're creating between functions. What let really lets you do is it lets you create variables that are confined to if statements or for loops, basically all curly braces. That's pretty much it. So the idea there is that, and the idea why ES6 is really pushing let is saying, like, hey, let's be even more specific and more refined about where you want to use this code, right? Like if I have a for loop, maybe my variables should only be accessible within the for loop, right? There's not really a good way to do that in ES5. In ES6 there is, and so let basically just says, now all curly braces create scopes, not just function curly braces. That's all it is in terms of scope for let. But like I said, wherever you see let, if you replace that with var, it should still work fine. Like it's like there might be edge cases where it doesn't, but like conceptually, like that's all it's doing, is that it's saying, hey, if I have a let variable, or if I use let to create a variable, I'll probably only use it in the scope. But if I use it with var, it will still run. The code will still run. So
the var is associated with 5, and let is when we start using let more and more. That will be when 6 is implemented more, because it's more of a characteristic of 6.
yeah, I mean 6 is just more stringent on the requirements about defining which variables you use and where you can use it. So that's pretty much all it is. So once again, declaring variables without var, don't ever do it. There's very, very few reasons why you would. And I think most code editors will actually, like, they don't give you error because it's not wrong, but they'll start warning, like, hey, this is a global variable, just so you're aware, are you sure you want to do this? And the answer is almost always no. Okay. Oh, and this is an example of why. Let me make sure that this is. Oh yeah. I mean, this is an example of why global variables are just like not good. In this case, on line 1, this is like the outermost parent scope. We can think of line 1 as like a global variable. Trust me, as a global variable. You'll see how different functions are editing it. But when we call it down here, when we call counting on you, we have no idea what the value of trust me is, right? Because other people could be editing it, and we just don't know. So, yeah.
Wait a minute, I'm sorry, I'm confused. I thought if we put the var in front of it, then that prevents it from being a global variable.
Well, this is not a global variable in the technical sense, but this is a global variable so that everyone else on this page can access that. Trust me, right? So it behaves like a global variable in this case. Does that make sense?
That's what I was trying to ask before.
Which is
No, what you just said.
okay. Cool. So we're good.
Yeah.
Okay. All right, great. Awesome. Okay. So that's just you basically want to know who's touching your variables. It's the short of it. Okay. Function and a function. Shadowing. Yeah.
I'm sorry, what's the suggestion for avoiding that then?
For avoiding.
For avoiding having like that in the previous page, the trust me being utilized like that in.
Oh yeah, totally. So in this case, right? In this case, if we want to, for example, say, hey, I only want like, let's say, counting on you to really modify whether or not trust me is it. Like, trust me should be declared inside of counting on you. Like, if we don't want this don't mind me function to touch trust me, don't give it access to the variable trust me, right? And we do it by defining this variable trust me in another scope somewhere else where it's actually being used, right? So if we look at this code here, we execute counting on you and say, are you equal to true, right? Well, if counting on you is the only place where we care about trust me, then trust me really should be in counting on you. It shouldn't be in the parent of counting on you, right? So the idea of only giving people access to the variables who need it, right? Like if you need this, have access to it. Otherwise, why? Right? Okay. Shadowing is this idea that and we saw this with parameters earlier. It's the idea like, hey, there is this universal thing, this universal variable that maybe by default, let's say like across the United States, across all 300 million people, the favorite apple is Granny Smith. But if I'm talking just about New York, the apple of the day is Fuji apples, right? So shadowing is the idea that like, hey, we have this kind of default variable that we can kind of assume, but in some cases we might override it. In this case, with our local version. But notice how shadowing, what do? We use var, right? We create our own version of this variable that's only used within this function. What are we not doing? We're not saying favorite equals Fuji, because if we did that, that would override the average for everyone else, right? So even in cases where we want to create our own local version of something to use, we still say var because we want to be very clear that, hey, we're not touching what this is. Because somewhere else down here, like, someone down here could be console log says the national favorite apple is Granny Smith, right? If we don't use var here, it will say the national favorite is Fuji, which is incorrect, right? Like the New York favorite is Fuji apples, right? So even when we shadow, even when we override parent variables, we still use var to make sure that we're not changing the parent. We're just overriding it for our own local use cases. Make sense? Cool. And then another way to shadow is just to pass and name the parameter, right? Because remember I said earlier, right? You just assume when you see a parameter that JavaScript is also saying var parameter equals whatever value you give it. So it's another form of shadowing, but just more implicit. And then this last one, just note that it exists. Don't stress too much about using it for now. There's something called immediately invoking functions. And the idea is, if I have something on the page that I want to run as soon as the page loads, what I do is I put that function in a parentheses, and then I put open and close parentheses to mean I want to invoke it right away. And usually for something like this, this is more for like if I'm going to a page, right? If I want someone to handle security stuff, like I don't want anything else to happen before security verify the user's passname or logins are correct, or I get the right data, right? So this is called a IFE, immediately invoke function expression. It just means make sure this is the first thing that runs when the page loads up. Yeah, it exists, but don't stress too much about it for now. Right? When you see it, just know that that's what it is. Good question, Justin? Or?
So what's unique is are we introducing something that has like a reserved word or anything like that, or just?
Yeah, I mean it's just this syntax here where it's like you have a function, but like if you see it, you're like, oh, why are we wrapping that function in parentheses first?
Oh, okay.
It's because we're preparing ourselves to invoke it right away.
Cool. It's a syntax thing.
Yeah. Yeah, and usually you'll see this like, I mean, once again, more of a habit than a demand, but usually you'll see these like on the top of the page, right? So someone who's looking at code knows, all right, I'm just gonna, these guys are triggering right away as soon as the page loads. Cool, let's move on to the rest of the code.
Wait, was just the B one more parenthesis on it? Or wait, because there's the first parenthesis in front of function.
Yep.
Then cool, and then you have string enclosed in parentheses.
There's a right here.
Then what's, oh, the other thing is just the thing.
Yep. So this is the first of the parentheses, and then you're invoking it with, in this case, you're passing it into a parameter. If you're invoking it without anything else, then this is just be string, but the open and close means you're invoking it. Okay. Sorry, let me just see. Okay, cool. Okay, so this is just okay. So the last concept is hoisting. And I think hoisting gets back to earlier, Dustin, where you're talking about with regards to kind of, okay, how does JavaScript actually start reading code? / can I run functions? Can I use variables if it's not sequentially in the page, right? Okay, so what JavaScript does when it sees a particular page where it reads a particular page of code is, in your mind, it might be like, oh, it just starts reading it from top down, right? And it starts executing it based on where things should be and jumps to the places they tell it to jump to. In reality, what actually happens is you can almost think of it as JavaScript reads the code twice. Okay, the first time it reads the code, what it's doing is it's looking for basically two things. It's essentially looking for var, the var keyword, and then secondly, it's also looking for function declarations or declarations. Yeah, I guess it's confused. Declarations, right? And so what that means is the first time, let's say you define 20 different variables on the page, right? The first time it does is it goes through and says, okay, I acknowledge that there are 20 variables on this page, and they're all undefined. I don't know what value they are, but I can acknowledge that they exist, right? And then the second time it goes through the page, it starts executing code, right? So if you're saying, var x equals 6, the first time it goes through the code, it basically says, okay, variable x exists. I don't know what it is yet, but, and this is why it does it, it says, if I see variable x being used anywhere on this page, I know that eventually it exists, right? That it's not an invalid thing. The second time it goes through code, it then says, okay, variable x, oh, you have a value of 6. Or if variable x is equal to a function and I want to invoke it, the first time all it does is say, hey, variable x, it exists. The second time it'll say, oh, you're a function, or oh, I'm going to invoke you. And so when we talk about hoisting, it's basically this idea that like on the first pass through of the code, it basically takes a bunch of things and it hoists or it lifts them up to the top of the page so that it's aware that it exists. So the example for it is in this case here, right? Okay, yeah. So we have this, outer inner output inner function, right? We declare on line, but line 1, right? And we're running down here. So we look at this one. Okay, this kind of makes sense, right? Cool. Now let's look inside this code. Here on the first line within the function, we have something called console log message 1, MSG. Inner function pass in MSG. Then we declare what MSG is equal to, right? And then we do a few more console logs. We call a few more functions. But the reason why this does not error out, or the reason why this won't error out is because when we call it, even though MSG has not been declared yet here on line 1, the idea of hoisting is the first time JavaScript goes through this code, it will at least acknowledge that MSG exists. I don't know what it is yet, but the variable exists. And so because of that, when it sees a console log, the first time it will pass it and say, okay, let's talk about, so the first pass through of the inside of this function, what JavaScript is going to hoist is two things. It will say, I know for a fact that MSG exists, because it's being created somewhere. I don't know what it is yet, I know it exists. And secondly, I know this function, inner function, exists. Okay? I don't know what it is yet, but I know it, or rather, I know it's a function, it exists. On the second pass through, I'm going to do console.logout message 1, and I'm not going to get a reference error. I'm not going to error saying MSG doesn't exist, because I know it does. But what am I going to get? Like, what's this console log going to give me?
The first time it goes through,
Yeah. I'm just making you guys guess right now, but
I would think it would be undefined, but you're saying that it can find it on the middle profile?
yeah, okay, cool. So we have a console.log out, MSG space MSG, and then here I do var MSG equals BCP. So what do you think is going to console log out on line 2 there?
Well, I would have thought it would be undefined, but if it can see it underneath it, then it's going to put the BCP.
Okay. Yeah. Oh, haha. Yeah. Cool. Okay. So in this case, we get undefined, right? Notice how if I remove this altogether, what is this going to get me now?
An error?
It's hard to see on that screen, but right. So this is a very common thing just to be aware of. That when something is undefined, it means var that thing was already created, but we haven't assigned a value yet. If you haven't declared it, if you didn't say var this, if it doesn't exist at all, JavaScript is going to yell over it. It's going to throw an error. Right? It won't just say, hey, this is kind of weird, but okay. It'll say, nope, can't do that because I don't know what MSG is. Right? It doesn't exist. And so even when you get reference errors, looking at the error is super critical to understanding what's happening, right? In some cases, it means I defined something or I created something but didn't define it. In other cases, it means I never created it in the first place. Yeah. So hoisting just to let you know, it comes back to this idea that when JavaScript reads a code, it takes a basic inventory of what's on the page first to know that hey, certain things are reference errors, as in these things were never created, versus trying to read it top down straight through linearly. And then now we come back to this fun thing we talked about yesterday, which is, hey, how come we can declare functions in 2 different ways? Well, the idea is when we go through this the first time, say hi will exist as a function because function declarations are hoisted, right? On the first pass through, it will say hi as a function, and this is what it is, which means I can invoke this function before I declare it. Technically speaking, when I look at the JavaScript line count, this will not work, right? Because the first time what's going to happen is on the first pass through, the variable say hi will be hoisted, and then JavaScript will acknowledge that the variable say hi exists, but it will be undefined. And then when you try to invoke it, it will say, I can invoke undefined. It's not a function. So this is why when I write code, I primarily use declaration I primarily use declarations as opposed to expressions. Although certain arguments can be made that if your code is in a good format, it really shouldn't matter, right? The order of it should mirror kind of how you want it to run. But this is also the reason why when you look at a lot of code, the first thing in every function scope or in every scope, people are going to list out all of the variables, followed by usually a lot of the functions. Or actually, no. People will list out all the variables first, just to make sure that later on in the code there's no reference errors, right? Then you have an option of, if you're using declarations, then what the common format I see is you have variables, you have things that you're doing, and then you have all your function declarations. Because the idea is when you run this code, the variable names gets hoisted first, right? Sequentially top down. The variable names gets hoisted first. Then the function declarations gets hoisted second. And then on the second pass through, it will actually run the code, the middle part of the code where you're executing it. But all that say you really should try to if you're using variables, always do the variables at the very top of the page for that very reason, because JavaScript does read it twice, and so in some ways order does matter in terms of when you declare things. All right, and then lastly, review. Scope refers to kind of your sandbox, your playground, the areas in which you can access certain variables. Right now, scope is only created by creating functions. we'll ignore ES6 for now. And things are in the function scope are the parameters, things you create with var, and also functions that you declare inside the scope, which in some ways are also kind of variable, but it is functions. And then inside a particular scope, JavaScript hosts variables and function declarations first, which is why in some cases you can invoke a function before you declare it when you read it top down from the page. And it's also the reason why why you should always have your variables at the very top of the page to make sure that they do get hoisted first. Any burning questions? Good.